Hello, welcome. Today we are going to continue with our class, and the topic today is about atoms and macromolecules. First, you need to know that the atom is a smaller molecule and matter consists of chemical elements in pure form. And when they are combined, they create bigger elements called compounds. Okay, so here you have a little video about atoms, so pay attention.
Hello everyone, welcome to Little Einstein. We're going to take a closer look at atoms. All matter is made up of elements that cannot be broken down by chemical activity. Atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks of everything in this universe, including ourselves. People often think of atoms as the smallest possible form of matter, but even smaller particles make up atoms. Each atom has a dense center called the nucleus. The nucleus contains neutrons which have neutral electric charge and protons which are positively charged. The number of protons in an atom determines the element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like the planets around the sun are the negatively charged particles called electrons. Electrons and protons attract each other. Usually, they are equal in number. Scientists ascertain a number to each element based on the number of protons in it, and a unit called AMU or the atomic mass unit, which is the sum of protons and neutrons present in the nucleus. For instance, a helium atom has 2 protons, so its atomic number is 2. It also has 2 neutrons. Adding number of protons and neutrons, we get 4, which is helium's atomic mass unit. Electrons have almost no mass and are not included in AMU calculations. In an atom, the number of protons remains constant. Individual atoms can lose or gain electrons to form ions. Atoms of the same element can also have extra neutrons. These are called isotopes. Despite having different neutron counts, isotopes retain their element's chemical properties because the number of protons remains constant.
Very nice. All organisms are made out of matter, which is anything that takes up space and have a mass. So matter can exist in many different forms and it could have many different characteristics. Like for example, rocks, metals, oils, gases, and humans are just basically mix-ups of different elements and compounds. As we know, in nature there exist 92 elements, like for example gold, copper, carbon, which is one of the most common one, oxygen, and many others. Okay, when these compounds are combined, they create substances, and they create a mixture of these different elements that, depending on how they are mixed, like for example sodium chloride, will have different characteristics. This is the periodic table where you can find the 92 elements that I just told you. So when we have mixes in different combinations of these elements, you will create new substances. And depending on how they are rearranged or they're arranged, they will have different characteristics. Though there are some of these mixtures or some of these elements that are essential for the life as we know. Around 25 of these 92 natural elements are essential for life. Like for example, as I said, carbon is one of the most common one. Of course, oxygen, hydrogen, nitrogen, they normally represent 96% of living matter, meaning that we are made of 96% of only these elements. There are others that are very important like phosphorus, sulfur, calcium, potassium, etc. And they remain in the 4% of an organism weight, okay? And they have also very important functions. You will see that most of the elements where you're seeing any chemical compound will always have this carbon or oxygen and hydrogen. Okay, so these are the basics one. and they have very important functions. Like, for example, in people that don't consume enough amount of, for example, iodine, they can create or they can develop this very common disease that it's called that the thyroid glands start to grow. Okay, we call this the goiter. And as I said, depending on the combination or how they are assembled together, these atoms will create elements that will have different functions. Each element will consist on a certain type of atom and it's different from the atoms of any other elements, meaning that they will have different shapes. And as I said, most of them will require or will have one of these basic elements, and carbon, it's always the basic. We also have subatomic particles. And as you saw on the video at the beginning, even though the atom is the smallest unit, it still have little or smaller units that are called the subatomic particles. We're not going to go very deep into this because we don't want to go into neutrons and electrons, but you just need to know that even though atoms are very small, there's still smaller units, though we talk about the atom as the smallest because it's the simplest one. And when we talk about the combination of these different elements, we are talking about the chemical bonds that are between them. Okay, so atoms are united together or assembled together with these bonds. Okay, and depending on the type of bond that they have, they will create a different type of molecule. Okay, so even though we assemble two molecules or two atoms, sorry, in a way, they can still create another molecule depending on the way they are assembled together. Okay, so think of Legos. Okay, you can unite two Legos figures. Okay, and you can use a little bond. Could be like a small square, or it could be like um, a circle, or whatever structure you want to use to join them together. Okay, so the stability of the structure will depend on that bond that you are using. And the strongest type of chemical bonds are called covalent bonds. Okay, there's still other type of bonds that I'm going to show you. Okay, so we have the metallic bonding. We have the giant ionic structures, okay, the simple covalent structure and the giant covalent structure also. So as you can see, they have different types of bonding, okay, and this type of bonding will depend not only on the elements that we're using, but it will depend on how they're interacting between each other. And just to talk about these big structures that the atoms or that these molecules together create, we have two types of molecules. We call them biomolecules. Okay, these are really big or really huge, actually. Molecules are assembled together and they're divided into two groups: the inorganic biomolecules and the organic biomolecules. The inorganics could be minerals and salts and water, and the organic biomolecules, which are usually bigger, are like, for example, carbohydrates, lipids, proteins, nucleic acid, amino acids, and peptides. Okay, so these are basically combination or different types of combination of these atoms or these elements, but they create bigger structures. So depending on how the structure is, they will have a different function. But what are these biomolecules? Okay, basically it's any of the numerous substances that are produced in the cells of a living organism. Okay, so proteins are the most common one, the most abundant, the biggest one normally. Many proteins are divided, okay, and they can be found many different types of proteins in a single cell. Your cell can synthesize proteins to do different functions, like for example, to help your hair to grow longer, to help your nails to grow, or to send a message to your brain to start creating hormones, for example. Okay, so when you think of proteins, think them as the text messaging that your cell is sending. Okay, so this message that will go and travel around your body to do a specific function, it's traveling in a protein shape. Okay, so normally we associate proteins with chicken and stuff we eat to make our muscles grow bigger, but actually proteins are all or most of the biomolecules that your cell sends as messages to do a specific function. Okay, proteins also are molecular instruments with genetic information is expressed. Okay, so they will contain, as I said, a message. Proteins can be built from a set of 20 amino acids. Okay, these 20 amino acids can be assembled in many different ways. Remember that it's not only about if you assemble one amino acid with other, but how you assemble it. So imagine the possibilities of proteins that there are. So as I said, think of them as building blocks like Legos. Okay, so you can manufacture many types of things, and depending on how they're organized, they can create enzymes, hormones, antibodies, transporters, and many other substances. Okay, so among the protein products, I think enzymes are the ones that are most varied and specialized. Okay, enzymes normally are particles that will have a specific function. Usually they are meant to cut things. Okay, like an enzyme to cut your lactose, for example. And these are some of these different ways of assemble the amino acids, which will create different types of proteins. Okay, so to end up here, your virtual classroom homework for this week is going to be you have to choose one of these biomolecules. You can choose mineral salts, water, or preferably, if you want to talk about more complex one, you can choose one of the organic biomolecules like carbohydrates, lipids, proteins, nucleic acids, amino acids, or peptides. And I want you to seek information about it. Make a very small summary. Okay, make it around 400 and 500 words. Okay, and just present it like in a PowerPoint. Make a quick presentation. Okay, just gather the information, make a presentation, be creative. Okay, make a PowerPoint that has a lot of colors, a lot of information, but not too much text. Okay, and I want you to post this on the virtual classroom, and we're going to discuss and talk a little bit about this on our next class. And that's it. Have a good week.